can be able to trace this, and I want to say that just in case you want to get the turning points of a curve or the stationary points of a curve, you've been given this from what I've been actually doing in my previous video. The question reads y is equals to x cubed plus x squared minus x minus 1. So I want to proceed from where I left. So you have been given this, and at the end of the day, I've shown you how you're supposed to get the dy dx, or the gradient function. So you have the equation as 3x squared plus 2x minus 1. This becomes our gradient function, or the dy dx. Procedurally, I've shown you what you're supposed to do. So from this point, I want to show you how you can be able to arrive at what you call the turning points of a curve, or the stationary points of the curve, and be able to actually see how we can be able to show the nature of the stationary points or the turning points. So the GF, or the dy dx, is, so we have what you call the gradient function, or the dy dx. It actually reads, it is here. So you have what you call 3x squared plus 2x minus 1. So the gradient function, or the dy dx, from our previous working is 3x squared plus 2x minus 1. So how do I get the turning points of this curve, which has been differentiated to get to this point, as now the dy, the dx, or the gf of that curve? Great. So I'm going to do this. If you get a curve like this, then you actually get asked to get the turning points, or the stationary points of that curve. First, differentiate the curve. After you've differentiated the curve, please proceed and get two possible values of x, in as far as working out, or actually solving that equation quadratically is concerned. So I'm going to solve this quadratic equation quadratically to get two different values of x. On getting the two different values of x, I'm going to replace in my original equation of the curve to get two different values of y. Great. So that means that now I'm supposed to actually do this. I'm going to say this reads ax squared plus bx plus c. I'm going to use what we call factorization method. I'm going to say sum, then product. So I'm going to write the sum is the coefficient of x, which is now b. So the sum is b, and actually in our case it is 2. Then the product, I'm going to say a times c, the constant. So a times c, which gives us 3 times negative 1, which gives us now negative 3. So the sum is 2, the coefficient of x, or the b value. Then the product is a times c, 3 times negative 1. That gives me negative 3. Now, which numbers do you multiply for you to get negative 3? I'm going to ignore the negative and just be able to say, obviously, 3 times 1 is actually 3. And in this case, if the product is negative, then one of these numbers must be negative. If the sum is smaller than these two numbers, when they get added together, that means one of those numbers must be negative. And because the sum is positive, for your information, then the smaller number becomes negative. So that means 3 times negative 1 is negative 3. And of course, 3 plus negative 1, the answer is 2. Good. So I'll bring down this equation and solve it quadratically. I'll be able to say 3x squared plus 2x minus 1. I'm going to replace which numbers? 3 and negative 1. Good. So 3 and negative 1. So this one gets replaced by these two. So I'm going to say 3x squared, then plus this one here, 3x, then minus x. So 3x minus x, that gives you 2x. Good. Then I'll say minus 1, the constant. So I'm going to actually look for the common factors. 3 and 3, that is 3. X squared and x, that is x. Then I'm going to say into So 3 into 3, 1, x into x squared, that is x. So when I say 3x times x, I'm supposed to get 3x squared. Then plus 3 into 3, 1, x into x, 1. So that gives me 1. So that means 3x times 1, that gives me 3x. Then I'll say minus. Common divisor of x and 1, that is actually 1 into 1 into x, that gives me x. So negative 1 times x, that is negative x. Then I'm going to say positive here. If I say positive, I'm going to say negative 1 into negative 1, that gives you positive 1. So negative 1 times positive 1, that is negative 1. That is to say negative 1 times positive 1, that gives me negative 1. Good. So negative times positive is negative. Great. I'll close the brackets. So I'll be able to say now 3x and negative 1. So 3x minus 1, that is it. Then because these are actually similar, I'll only pick one. So I'm going to say x plus 1. I've solved the equation quadratically. After that, I'm supposed to get two values of x, in as far as the turning points of that curve are concerned. So I'll come here and say 3x minus 1 is equals to 0. So I equate to 0 for me to get the turning points of that curve, in as far as the x value is concerned. Then I'll come here and say x plus 1 again is equals to 0. So I'll take this on this side. Again, I'll take this on this side. The negative sign becomes positive on crossing the equal sign. So that means 3x is equals to 1 plus 0. Great. Then I'm going to have 3x is equals to 1. So divide by 3, divide by 3. So that means my first value of x, and as far as the turning point of the curve, is a third. Great. So when I come back here to this other one, I'll say x plus 1 is equals to 0. So I'll take this on this side the way I've just said here. So I'm going to have x is equals to 0 minus 1. So that means I'm going to have x is equals to negative 1. That's the second value of x. So I'm going to actually go back and get the equation. So this is the x value, and as far as the turning points of that curve are concerned. So I'm supposed to get the corresponding values of y. I'll go back to the equation. It reads y is equals to x cubed plus x squared minus x minus 1. Because y is equals to. So when I replace the values of x I've gotten here in that curve, I must be able to get the corresponding value of y. So I'm going to write it down here, and I have it as y is equals to x cubed plus x squared minus x minus 1. Now, when x is a third, what is y? Where is that a third? It is here. I think we got it. When x is a third, what will be the value of y? Good. So I'll just replace here. So I'll say y is equals to x is a third. So I'll say a third cubed, then plus a third squared, then minus a third, then minus 1. Okay, I'll have to use my calculator to be able to arrive at the answer. So this is my calculator, and what do I have? I have I'll put it on, and I'll say open brackets 1 over 3, close the brackets, then cubed. Good. Then plus again, I'll be able to say open brackets 1 over 3, then again close the brackets, then squared. Great. Then minus 1 over 3, then minus 1. So the answer is negative 32 over 27. Good. So that means the value of y here, y is equals to negative 32 over 27. Or I can be able to write it as a mixed fraction. I'm going to say y is equals to, so this goes into this how many times? Negative 1. What is the remainder? 5 over 27. That's the first value of y. So again, I'll write the equation down. Y is equals to x cubed plus x squared minus x, okay, then minus 1. So when x is negative 1, what will be the corresponding value of y? So I'll come and replace again. Y is equals to 1 cubed plus 1 squared minus 1 minus 1. Okay, so 1 cubed plus 1 squared minus 1 minus 1. So that means, let me just write it. So 1 cubed plus 1 squared. Okay, it is here. I'm just replacing. Let me put it here. So 1 cubed, then 1 squared, then minus, open bracket, negative 1. So close brackets, then again I say minus 1. That gives you 2. If you want to make your answer much easier for you to be able to get it, you can just say, you'll open the brackets, you'll put negative 1, you'll close the bracket and then actually say cubed, then you'll say plus, again open bracket, negative 1, close the brackets, you square, and again you say minus, open bracket, negative 1, close the brackets, because it was negative 1. So I'm supposed to actually put those negative signs to make me get the accurate answer. So I'm going to say negative 1 cubed plus negative 1 squared minus, open brackets, negative 1, the value of x here, then minus 1. Good. So the answer is 0. The answer is 0. Good. So that means y is equals to 0. So what are the turning points of that curve? Turning points. So I'm going to have, when x is a third, y is negative 1 and 5 over 27. When x is negative 1, the y is 0. So I'm going to say a third, then negative 1, 5 over 27. Then negative 1, then 0. The turning points of the curve.